I will comment on the subtitle of this particular before getting into details later. I'm Claude Gibert, I'm French, I've been in the UK for quite a while now. I've been in the world of meteorology forever, basically. My first job was for the French Met Service, EuroPython. Meteorology is interesting because there's a lot of computing, a lot of processing, a lot of post-processing. And I worked particularly for the European Centre for Middle Range Weather Forecast, EuroPython, for 12 years in their operational department. So I'm one of the people who committed many of the operational systems there. And I'm currently working for myself for Directive, and I currently work for the Global Modeling and Simulation Office at NASA, and they are in charge of data assimilation. They used to be the DAO, Data Assimilation Office, and they now also generate weather forecasts for their own services. It enables them to calibrate satellite sensors. Data assimilation basically consists in gathering as many observations as you can and trying to get a good picture of the atmosphere at some particular time. Saying in a very small sentence, it's very complicated to do. Weather forecast, as you know, that tries to predict what the weather situation will be later, and it is done by running physical models. And what we do very actively is to verify the quality of the forecast for different purposes. First of all, if you sell your products, you want your customers to have an idea of the quality of what you've been selling. And if you want to improve your model, you need to have some way of assessing the impact of your changes. So forecast verification is very important. It's a very active field in meteorology. There's a lot of research being carried out there. Besides, there is also observation statistics, which is basically monitoring of the observing systems, spotting when the observations are wrong, and so on. I'm mentioning all this because I'm going to talk about the work I did on two different projects. One on the forecast verification system, the other one I'm currently doing for NASA on observation statistics. That was just to lay the background. I won't talk about meteorology much anymore. Okay? So it all started in 2004, which was not early days for Python, but it was early days for acceptance of Python in different organizations. I would say also early days for acceptance of scripting languages. I worked in CCWF. It's a company where Fortran is used for modeling, and C++ was used for pretty much anything else, I would say. So it was quite difficult to look into new languages at the time. And I was tasked with a new project to replace the good old verification package they had with a new one, knowing that the new one would deal with many, many more types of forecasts, so it was impossible to modify the old one. And I extracted a few points. Obviously, that's not the whole project, but first of all, the interface to the system was supposed to be text-based. Shouldn't require programming, so users were not expected to learn a language to use it. But it was using batch processing, so we definitely needed something which was, let's say, text-based. It was supposed to retrieve data from the archive, compute statistics, store statistics, then extract them and plot them. It sounds simple enough. It's not that simple. So, offering a text interface, there are obviously lots of possibilities. You can invent a syntax. And I wanted to show here that for the archive there was already some sort of syntax used, Lasagne. If you wanted to retrieve data, you stated retrieve. You define more or less what you wanted. So that means there's a long collection of parameters. These are just a few. We don't get anything with that. It's quite a complicated archive. And required to learn the syntax, but no programming. So that was one way of doing it, but I didn't see the point in doing that. I just meant to mention as well developing a language doesn't make any point, and I get really annoyed with scientific packages like MATLAB, IDL, PBWave at the time. Even in-house at the Earth, there was a scripting language for manipulating fields. The problem with those languages is that they're maintained by a pool of programmers. If you need any new features, if you need external modules, either you have to write them or you have to wait for them to include them. So I've always been pretty much against all that. I'm going to come back to this. Just wanted to add a few things to explain how the thinking was going to get to the conclusions I made. Retrieving data is difficult. This EuroPython has got n petabyte archive. I don't know what it's like now anymore. There are lots of fields in there, lots of observations. So identifying the data requires some skills. You have to decode the data. There are different file formats which are specific to meteorology. They are produced by the World Meteorological Organization. So you have to decode the data, and you have to have enough knowledge of the archive as well to know that if you want one particular meteorological parameter, it's actually not archived. So you have to probably de-archive 2 or 3 others and compute it from the 3 others. So there is a lot of skill in retrieving data. So that wasn't a small part of the project. Computing statistics, despite the fact that verification is an active field of research, and I mean, there is a lot of science in there, at the end of the day, you get a couple of equations. Well, I don't want to undermine the work of the researchers, it's difficult to get there, but at the end of the day, all you do is compute some mathematical formula. It's not that complicated. The main problem is to know what you're computing it on. If you're verifying a forecast at day 5, you have to wait for 5 days, take the initial conditions of the 5 days later, and make sure you compare the lag. Sometimes you want to play some tricks with that as well. So pairing data is complicated in the sense that there are lots of fields. In terms of quality assurance, you want to make sure that you are pairing the right fields together. So this is the big thing about computing scores. Storing statistics, okay, well, I'm not going to talk about this today. We ended up with a SQL database, PostgreSQL. I actually learned about non-SQL databases in more detail this week, but that's out of the scope of this presentation. A particularity both for verification and observation is that normally the metadata is at least 20 times bigger than the data. And that's really annoying when you databases. And sometimes when you compute building squares, for one float you store, I don't know how many bytes.
Is that an operator? There's a common format NetCDF or HDF to use this instead of databases. So you have much less of overhead of data.
Yes, I use HDF, that's more in the US actually. I use it. Yeah, I do use it. But the official WMO format are grip and buffer for operations. Yes, I agree, you can write flat files, but you don't have the same speed of access.
As in the sequential database, it's integrated, so you can get a lot of dependency just this one column, and you can get some parameters based on others. It's similar to the database.
Yes, I don't deny it's one of the possibilities. We chose SQL for the good reason that we had some SQL administrators on site and they did the job for the design and the maintenance and the backups and everything. It's more of an operational issue, I would say. But it's a good point. Okay, the last stage of the system is to extract from the database and plot statistics. And that's the visible tip of the iceberg, and that's the very important thing. We will see that, I will develop this because I'm going to show how I solve the problem of plotting for that particular case. We will see that plotting is not easy basically, because the user wants to have enough control on everything. You know, style, color, type of curves, how to organize the plots on the page. You write the paper, you might want something in particular, you might want to customize all the text on the. So that was challenging, and what I'm going to do today is explain the first part, which is the text-based language interface, which I decided to design, and how to develop a plotting system with that, basically. This is what I'm going to talk about today. Still, in the thought process I was in, I realized that this package was going to access the archive, big deal. Decode data, not such a big deal. Identify data, post-process it, pair data before computing, compute, store, and plot. And that's what 90% of the programs at EuroPython were doing, basically. Some in C, some in Fortran. The code we used was mostly copy and paste. You go to the office next door, you have a program which does that, yes, send me a copy, they modify it to their own needs. But as soon as something changes, then you have 90 programs to change. That's one of the issues. So it occurred to me that if I could first develop a framework which could do all that, and then as the user of that framework, I would develop the verification package on top of that, we would have a framework for Python developers, basically. Oh, I gave it away. I chose Python, essentially. That's what I'm saying here. Well, which language should I use? I have to say that at the time I wasn't sure. I really wasn't sure. I needed to glue libraries, C, C++, Fortran for the decoding, some scientific routines, I would say. I knew Perl. I finished a big project in Perl for web application, and I knew that Perl was a no-no in terms of syntax. It's good at a few things. So I learned Python in one day, and I tried it, and I thought this is marvelous. I'm going to use it. So I've said this already. This is what we're going to do today. First of all, the text-based interface, because we need to convey lots of information to the application. Non-expert user needs to do that. And on the other hand, we'll see that it also supports the developer. So if we go back to this text I showed at the beginning, this retrieve statement, it looks very much like a dictionary. So it can map to Python very easily in the box at the bottom. If I have a class called retrieve, which inherits from some flavor of dictionaries, it's very easy to specify exactly the same. And I call that a directive. You can note that people don't need to program statemental. For me, keeping it statemental meant no loops, no if statements, just inline code like that. So people were actually writing Python without knowing it. I don't know a very good reason to do that, because I thought already I didn't want to make a few of the things customizable. And if we use Python for the interpreter, then we can pass actually some code directly to the interface. The only problem is that we need some semantics in there. A dictionary, okay, it only takes the meaning of what you put in it. Okay, Python doesn't help you at that level. Python helps you with the syntax. So I needed to write something which enabled me to deal with the semantics of every directive I was going to deal with. So if we use the dictionary, I'm using here as an example a Python dictionary to describe a directive which would be called store. And I'm enumerating a list of keywords, name, age, nationality. Okay, that's not much, but now if I write a library which takes this, maps it to my dictionary given by the user, at least I'm able to say, okay, well, you're mentioning first name, but I don't know that. I'm supposed to say first name, and so on. Why dictionary? Because they're very powerful. So obviously it was a bit more complicated than that. Otherwise it wouldn't have been useful. So I'm going here straight in the subject by showing you a directive, which is an observation. So this is about the current project I'm working on. Just to give you a few examples of what is part of it. So you can specify a type for each key of the dictionary is called a keyword in the user's language. You can specify a type for a keyword. You can specify aliases. So the official name is domain name. So in the application, we will always use domain name. But the user could type domain. Okay, it will be substituted later to the official name. They can have default values. So try to save some effort to the user. If they don't have a default value, they can be declared optional, so the user don't need to enter them. And there are validators as well. Validate, so there are some standard ones. Validate shows, it means basically here that the only two values which can be held in that keyword are OP and IM, observation impact. You can write your own validators. So you can, often you have validators which actually check that it's part of the keys of a factory or something, just to, it makes it very dynamic. So this describes a directive which, so I'm sorry, I hope you can see that. On the top left you've got the previous slide, it's exactly the same. Bottom left I'm showing you that all you need to do basically is subclass the directive. The check language is when the action is done, actually. It's not done by default in the constructor. We will see later why. But all I need to do here is call the constructor check language. We're not worried about language here. The language reader, I wrote it there to remember to tell you. The language takes a dictionary as an entry. So you can either write Python dictionaries and load them, or XML. At the moment I use JSON. But actually writing this presentation was good, gave me a few ideas. So at the moment I'm using JSON basically. You can write the reader you want. You could receive it from an HTTP request. So on the top right corner, we instantiate our class observation. We want to print it. Okay, the language is doing its job. It says hold on a sec. You said variable was required, and it's not in there. KT, KX are the real names that were in there. Observation type, observation source. KT, KX are missing, and they should be there. The date is missing. Okay, doing its job, right? Next box. Wow, we decided to play the game. We put a bit more values in there, and we print the results. I just want to highlight the fact here that the variable, for example, the domain, the type, we get in there. The type is entered as a list, and it comes out as a single element. It's because it is defined in the language as being unique, so it guarantees for you that your application can assume that it's expecting not a list to direct value. If a list is expected, the application guarantees that the list is given to you even if there's one element. So that's how you support the developer by, and I can assure you, you write much cleaner code. You don't need to check every 5 minutes what you're dealing with. You have a guarantee that what you get is what you wrote in the configuration files. So, writing this presentation as well, I realized something. I realized that taking a subgroup of what I have for the language there, I can actually write something to check arguments in Python. And it would be a pretty good either argument formatter or at least debugging tool. I wrote a decorator, and if you decorate your function with checkout, you register, and there are many ways of doing this, okay, I did that quickly this week. You register the description of your directive, your dictionary, basically you expect your function. Then, whenever you call that function, KWRs are checked against the language definition. So in that case, we call my class, we instantiate and call my class with A is 12 as a list and D is 10. D is aliased, I don't have a pointer, I'm sorry. D is aliased to, sorry, yes, D is aliased to B, so it becomes B in the directive. A is declared unique, so although we send an array comes out, at least it comes out as a single value. Okay, I don't want to emphasize too much, but this is, I think, a pretty powerful debugging tool, at least during development time, to check that what you get, what you want. And besides, as I said, it's very nice not to have to check if you receive the list or not the list, and so on. Okay. So defining a directive is a bit like writing a class, basically, or you're writing a class of dictionaries. You want to have the same, like the same rules, let's say. And just the same way classes can inherit from each other, well, directives can inherit from each other as well. So if I define a surface observation here, for example, it's going to inherit from observation. Well, I'm going to specialize it and say, hold on, the level default value is 0 because it's surface. And you might want to add a new value, which would be it's a station height, if it's an observation, maybe at a station somewhere. So you can easily derive new directives from existing directives, just like subclassing. Multiple inheritance is supported. You can multiple inherit as much as you want. I just wanted to point out that the inheritance of the classes doesn't have to mimic the inheritance of the directives, because you associate the class with the directive, and there's no need for that, and often you don't do it, basically. There is also another mechanism, which is the specialization. You can define a directive and dynamically, depending on the test on its keys, you can define what it's going to inherit from dynamically. So here, for example, specialized from the statement they write. The keys are valid Python expressions, which name keys of the directive. And if they evaluate to true, the first one which evaluates to true gets the name of the directive to use to specialize the object. And at the bottom in black, you have the directive impact, for example, where you say, well, an observation impact has the name correlates there, so by default, it's going to be there. Okay, now let's carry on with the directives. Once directives are defined properly, we can deal with dictionaries for which we know the values, we know the form. Instances, actual directives, can inherit from each other. It's not an inheritance like a class inheritance, it's a dynamic inheritance from the values. For example, the directive implements a few methods, like child inherit from a parent. So you can take two directives which are two directories, they don't even necessarily have the same definition, the directive definition. And the child will inherit anything which is everything which is in the parent, which is part of its language, which is not a default value if there is already a default value. So the inheritance is always in the direction that if the child already has something, it keeps it. We don't override it. There's another one which is the opposite. If the child has a default value, it will be overridden with whatever the parent has. It may sound weird now, but we will see that it makes sense when we actually apply it. All this is done recursively, obviously, so if a directive has directives in it, the inheritance works the same way. And for the directive, the set item method is actually extended. The set item method keeps track of default values. So at the beginning, we know what was there by default. if whenever we use the square brackets to set the item, we keep track that the value is not a default anymore, because it's important for inheriting from other directives. So let's try and make sense of all this. It may sound a bit complicated like that. Plotting. How do I do this plotting module? Plotting is not that simple because everybody seems to do it manually. And I actually went on the internet recently to look at different graphical packages. I use Matplotlib, by the way. They show you there is an example, and the examples are always very manual. Line 1, I do this, line 2, I do that. If you want to plot an axis with a date, it becomes plot underscore date, while it's plot normally. So it's not very practical to say, hey, I want to plot. I don't really care whether it's a date or not. X-axis, Y-axis, so you've got this method which are X-axis something, Y-axis something, so it's not extremely interchangeable. So most libraries I've used so far are difficult in that respect to handle automatically. It seems that the developers of graphical packages never actually wrote software except examples. I'm not doing that to criticize it. And in Cellograph, I used the enhanced graphical library, which I had to work completely because I had the luxury of being able to talk to the developing team because they were there physically. And to them, the concept of designing plots dynamically just didn't make any sense. They just couldn't get it, basically. And that doesn't make our life any easier. So, how can I express with my directives that if we look at our observation, we've got a few fields, KT, KX level, so we can have many KTs, many KX, many levels, many domains, many weights, many statistics. Now, I'm thinking, I'd like to plot this because I want to compare that and that. How can I specify that I want colors on a plot? And each of them is KT, KX, and a different domain. Or how can I specify a plot where each of the curves is a combination of KT, KX, but this time I'm on different levels. We want to look at something different. And what if I wanted to have different levels and different domains? All on the same plot, or maybe I want them on different plots, because it's nicer to have them next to each other. So, I use the document plot model, where each directive inherits from the observation I showed you. So, the definition of the observation with a few fields I mentioned. And the document contains the attributes related to graphics, whatever they could be, maybe color. So these are attributes we would set at document level. Attributes related to layout and output. I want to generate some PNG. I want 4 plots per page. I want whatever. Attributes related to the data being plotted, very important. That's our observation directive. We inherit it directly from the observation. And it has a list of plots. Plot objects, plots which are templates for what we want to see in the page. I'm insisting on template, and I'll come back to that, because a document could have one single plot in the list, but still produce 20 plots in paper. This plot is used as a template for different values. I'm going to explain this. The plot directive is also an observation. Again, we have graphics related to that plot. We have the data being inputted, some title, whatever else we need to have. And it's got a little of curves which again are templates for curves. And a curve, well, can have colors and styles and everything you might imagine. Attributes for the data being inputted. Some legend, maybe, that's how you differentiate curves on a plot. So the construction of putting all these directives together, knowing that all the verification is done by the language, default values will be set, so the user doesn't have to specify everything. There will be some inheritance going on there to make sure that all the parameters, all the different, let's say, if you put graphics attribute at document level, they will actually be spread over all the physical objects at all levels, but using inheritance. And because we use inheritance, the lower down you go in this construction, if you go to curve level, if you set a value at curve level, it has precedence over anything else. Okay, so you could very well say in your document, I want my line is green. If a line level you see it's red, it's going to be red. So here's a working, I think, example of a document plot curve. The document has we specify type, level, statistic, whatever we think at the higher level will be common to everything we plot. We say we want a time series plot, so it's a special kind of plot. We've got dates at the bottom and whatever else on the other axis. Please note that this is not well formatted because it's work in progress. So I'll make sure I plot everything properly. I will be worried about the cosmetics later. Unfortunately, the cosmetics will take me longer than the rest of the work. Our time series plot has got a list of dates, obviously, because it's time series plot. And we've got a curve, which is a line. It's called a line. And because the document we will see why knows that the domain needs to be spread over different plots, we're generating two different plots with one curve on each. I guess it's relatively straightforward. Now, if you watch this red line domain, the global North Hemisphere, just move to plot level now. Here it was here. It's all identical, except that I moved it to plot level. And the plot also knows that it needs to spread this domain. So the result of this is one single plot, because there's nothing to spread from the document, but two curves. Okay? So that's how you can actually, by moving the statements up and down, this is how you can control how your plots are organized. This is a more complete example, but I wanted to show that we've got a document, time series plot, same. Curve. This time I actually mentioned two curves, one is a line, one is a bar. One is on the global domain, the other one is on the North Hemisphere. And as you can see, graphics attributes can be set here. This one is black, the other one is hidden, it's orange. And we actually get two curves, one bar, one lines, and you can see the colors override everything. I put the domain here in red in the time series plot where it says South Hemisphere and tropics, because it's not taken into account at all. It's not taken into account because the domain is specified at line level. Okay, it has precedence. Who could tell me? Sorry.
I think there's a question. Who wants to know? Yeah. This looks to me currently like a very fixed format, which makes some inputs and some curves. Do we expect that some scientists work together with you to extend this for their needs, or is it just a task to make a little set of which can be possible by plot algorithm to be done?
No, you don't expect the scientists to extend this, but you can imagine to put any kind of directive in that you can plot all sorts of data. It's supposed to be a framework for plotting.
Yes, maybe they want error bars, maybe on the graphs.
That's sure. I mean,
So,
how will I develop that?
yeah, or weighted error handling, or weighted regressions or something like this. You have not developed. So that means they have to ask you how can they contribute in this kind
Yes,
of...
they can contribute in the sense that there are keywords in the directives. I was going to come to that. There are keywords in the directive which can be callable, where you can actually pass a Python function
Yes, but this did not look like normal Python code. That was the question.
It is normal Python code. That was the whole purpose of this language. This runs in the Python interpreter.
Yes, it runs in the Python interpreter, but the user who learns Python did not see that he has to access objects like this in a dictionary or in the list. Usually someone makes an object and then he enters the derivates from his object, and this is a derivation from another object already. It's similar to your own language in Python for plotting.
Yes, that's what it is. That's what it is. I wanted to have different level of access. Okay? The standard user would not program. So the standard user will use this. I'm going to come to the customization soon, or we'll be running out of time, and I can also have a question for you later. Yeah, in this example, could someone tell me what would have happened if I didn't put domain in the curves? Like domain equals global, domain equals North Hemisphere.
Default value?
No, because there's a domain in red in terms of its plot. So we would have got South Hemisphere and province. But how? Okay. We would have got actually 4 curves. I don't know that, which can be something we want. We would have had 2 black curves, 2 olive curves. And it's because these curves are not physical curves but templates. So the plot knows that it's got South Hemisphere to apply to each of its curves, and then tropics to apply to each of its curves. Okay? So that's why I call them templates, because it's not number of curves which you can number of curves you're going to see on the plot. I was worried actually when I implemented this about how people would understand it, and in fact it worked really well. Provided you, I wrote a clean example for every type of plot. And again, it was copy-paste. People, after a week, they were spread everywhere, and people followed really well. This is documented as well. Just a quick word here. Okay, that's another plot, which explains it as well. What's important is I also use the directive definition to hold the parameters for the programmer. So any key starting with underscore is actually not printed out. It's a hidden key. And here I'm saying, well, this is time series plot. So what is combinable, meaning what I'm going to spread to all my curves, is the domain name, statistic, and level. I don't want to spread the date because I'm a time series plot. So for each curve, I want to have a list of dates. Okay? And I have another key, which is the index, which says we are going to take plot against the date. Okay? So now, if I take a vertical cross-section, the list of combinables are the domain name and the statistic. Over the date, actually, here I didn't mention it, but for observation statistics, actually store in the database intermediate results. And I can then aggregate them in any sort of directions depending on how I use them. So here there's going to be an aggregation of all the statistics over the dates. And we plot against the level. Now, this sounds like nothing, but if you want to develop a new plot, all you have to do is define a directive which inherits from the plot. You define the right combinables and the right index. And what you have to do is to redefine the draw method, where you get the data already prepared and sorted exactly as you want it. You can actually, if you want, put 2 indexes and draw a contour if you want it. If you want it to. Okay? I will probably have to do some contouring as well. But, it's very easy for the developer to write a new plot. Because all the recursivity stuff, all the spreading, everything is done in the base classes, it's done behind the scenes. Well, these are plots generated using this directive stuff. Some of them can. This is a standard plot that you get on the monthly observation statistics. These are from the previous project in verification. So these have got decent titles. They have decent titles, decent formatting. You can see there's some contouring. There are some error bars in there. Scattered plot. What's interesting is the top left is the mean of whatever score that is, and the black line is a running mean or overall, maybe 12 months. And the black line is to be expressed as a function of the red line, because it's just a running mean from the red line. So that's something I haven't done in the new project. We have curve arithmetic as well. We could actually add curves or make differences between curves, which is quite powerful too. So the directive is not very sexy seen from outside, but it is good for the user because first of all, there are lots of default values. If they make a mistake, hopefully we will pick up and tell them about it. I didn't show it, but you can add the help keyword in each of your keywords. So by default, we can display the help for that particular keyword. So there is quite a lot of support for the user, which is a good thing. But there is a lot of support for the programmer as well, because the programmer knows that what he receives is true, and that's extremely important. Yes, I prepared this one. This is something I drew for the computation of scores for verification for CMWF, where it would be good to have a pointer for that. But you have, first of all, you have the user's directive, which is a collection of directives. It can be as complicated as you want it. And you have a compute engine, which is able, using its metadata and the user's directive, to create a list of requirements of all the data which is going to be needed, compute the right dates, compute everything we need, depending on what the user wants as well. It retrieves the data, decodes it, and loads it. So at some point we have a compute engine with data in memory, everything which is required for whatever we are doing. Here you can actually specify in the directive a callable. It can be a function, it can be an object, doesn't matter. The function is an object. And at this stage here, between the decoding and loading in memory, you can actually apply whatever you want to apply to your data. For example, this is where if you deal with ensemble forecasts, if it's forecast with lots of different forecasts, you can organize them the way you want it. You can do some time averaging, you can do many things at this level. Once you are at this stage, you want to compute scores, and before that, you might want to apply the bias correction to your fields. You might want to compute a mean of fields which are already loaded, because you also want to score that mean. You can compute masks like C, lambda, or whatever. These are examples in Meteorology. So that's the second point where the user can actually pass something to customize. And I'm answering the question here. Then the computation of scores, you can define your own scores. All you have to do, you need to subclass a class, but it's writing two methods really. And that's how I managed, at the beginning I explained that you have to pair the data. And this is a good way of saying you can write your own scientific stuff at a point in the process where the data has been retrieved, decoded, and paired properly. So it takes a few lines to write a new statistic. And then there's a storer, which by default, there's one to SQL. I'll have wrote one for MongoDB this week. There's one writing in an ASCII data file. And you can actually write in all of them at the same time if you want to. It happens. And you have a database. And there are more rows here because in the verification system we pre-computed some tables which we then used to compute more scores. So the data didn't always come from the archive, it could also come from the database.
Thank you. I think there may be some questions though. it's okay. We can talk about it now. We still have a few minutes. How can you handle data plots which are neat? Maybe you have a contour plot, and then you want to have a region of this contour connected by a line, and another line maybe which should show a third dimension will change for every data point to other.
At best, yeah. At best, I can
just want to describe a very complicated plot.
So, I mean, there's a limit to automatism. Having said that, a lot of verification plots are always against the control. Okay, so the plot, bottom right plot here is an experiment against control. But I also make sure that when the experiment is better than the control, it's positive. So I have to turn the statistics around and for that. But that's how we supply tools to compare against the reference. But at best, for your question, we can put them next to each other. But I haven't interfaced anything. Everything's possible. As long as I provide the user at directive level with the right keyword to go into the graphics package, it is possible. Annotations are possible as well.
The question is this code available? Is this published somewhere?
It is not at the moment. The current one will be because it's the government, the American government, will give the code. It will just take paperwork, and I will need to ask them to do paperwork, and it will take weeks. But it will happen if anybody is interested. Yeah. So yes, it will be available. Not right now. Not. It's owned by Lasagne. Yeah. And the other one is from ECMWF, and they don't give it away.
They have to check cards with passwords.
No, it's not their policy to give a kind of code, except to web services, because it's actually running in Australia, and I'm going to install it in Spain as well. So.
Okay, other questions?
Just from seeing what you had for directives, did you think about how is that dissimilar from doing abstractly form validation?
Oh, it's probably the same, yes. To your point. Exactly. You could use for that.
Okay. Okay. I think we are done. Thank you very much.